Hello, everyone. So I have been working on a programming project, and I decided that I wanted to start sharing some of it on YouTube to, one, make me accountable to someone, um, to continue working on this so that I continue to make progress, and just to talk about it because there's this theory called the rubber duck theory. When you talk about things, even if it's an inanimate object, it can still help you process what's going on. So I thought it'd be good to do that. So to get you up to speed, I'll tell you a little bit about this project. So there are going to be three people working on this project, me and two friends of mine, um, and it is a security system. So the goal of this is to use Raspberry Pi nodes and create a system that can detect when someone or something opens or closes a door or window and trigger cameras that would be looking at those doors or windows to turn on and record for a certain amount of time, save the file, etc., etc. So each of us have tasked ourselves with different parts of this project, and my section was the camera node, um, which is the one that will receive a signal to record. It will record for a certain amount of time and then save that file and be done. Um, Possibly adding um, motion detection through the camera, but well, that'll be later. That's just a future idea. So I'll kind of show you some of the code that I've made already. We're using C++, and currently we're just using Raspbian to test things. We should be able to use basically any Linux operating system. I do need to learn Linux well before I can start to do this project, but anyways. Um, so I made something called a queue, and it's a thread-safe queue. That's why it's called QTS. Um, and this queue I'm going to try to use for sending the different threads work descriptors. So, for example, if we have a networking thread, I'm assuming I'm going to stick different processes in different threads. So a networking thread would have this queue, it would make a queue, thread safe queue, and then whenever you wanted to add an item to this queue, maybe another thread wants to send out a request or something, it would then be able to do this safely. Um, this queue would handle the multi-threaded stuff and it wouldn't break because of improper accesses. Um, so this would allow it to talk between threads and have they all can communicate with the networking thread and everything just works. So I thought that might be a cool way to handle that. I can't think of anything else, so I would have to think about that a lot more if I wanted to try something else. So I need to improve this a little bit. Right now my length is just get length, and it just gets the length, and it could change the next second. Like it doesn't. So I want to be able to almost have maybe a remove if or something, because if another thread removed, and now you look at the length and it's 1, and you try to remove, but they just removed it because they're in a separate thread and they can do that. There would now be 0 even though you're trying to access it, and all of a sudden you're not getting anything. So it might be a good idea to, even though I am only planning on having one thread remove, it might be a good idea to have the length be in a way that when you call remove, it freezes all other accesses. But I'll have to see about that. Um, but yeah, so I made this. It does work. I just tested it. I don't think I can see if I can add another source. Hang on. Um, for my screen capture software, I want to be able to add this other window. Okay, so this other window should be able to window capture. There we go. It's probably going to overlay directly over Visual Studio, which should be fine. I don't think that will be an issue. Okay. Let's see. So if I run this, you can see it running. And there we go. What this is doing is it's continually in. I think I have 200 threads, 100 threads. I have 100 threads, and I'm making 1,000 adds and removes per thread. And you can see nothing's going wrong. I'm using something called Visual Leak Detector to detect leaks, memory leaks. So it is working great. When it exits, which will be, that is taking forever. It's supposed to make 1,000, so my computer might be running slow since I'm recording, but just understand that it was working. I did test it, so that will complete. I know it's printing out weird because the multi-threaded access to cout doesn't work perfectly, so sometimes it will miss the new line character or start printing in the middle of another one's line and can get weird. They should all be aligned, but they're not aligned along here. So yeah, the plan for the future right now is to start working on the networking. That's my task. There's another friend of mine that is going to be working on the camera stuff, and so we're going to be working on the same node because there's a controller node, and that is what my other friends, I'll say first friend, second friend. Second friend is working on the camera, so I am going to try to work on the networking, and that is actually going to be used on both nodes, so that will be fun. Hopefully I will be able to communicate with them well. We're all remote currently. I'm on a co-op, and the other one's on co-op, and the other one's in school, so communication isn't perfect, but we have Discord and Skype and texting, so it should be fine. So I can kind of explain how this works. So my idea with this is to explain how I do things and show the logic of what I'm doing and explain that to you so that I can better understand what I'm doing, because just saying it helps. It does. And if I'm doing something incredibly stupid, hopefully you guys will be able to help me and show me ways that I can do something better, or ways that I should just completely avoid because they're incorrect. So how about we start with the queue, since that's really mostly what there is. Oh, they're finished. You saw that. It reached its 1,000 limit. And if we go to the output, they all exited with code 0. All 100 of them. Visual leak detector was good, so it works. So I have a class in here, and then I have an embedded class inside of it as a private class, one that you won't be able to see because you don't need to. They're template types because I'm sure there's better ways to handle this, but I just wanted an easy way to be able to, for example, if you look here, I say it's a string queue, and then it's a string queue, and you know how to deal with strings. When you say remove, it removes the string and gives you a pointer to the string. You don't have to worry about anything, which is really nice. Where if I would try to do something like manually allocating the number of bytes necessary and then returning that, and they would have to cast it as a type of whatever they wanted. I couldn't think of any good ways to do this other than templates, so I did. So the class is pretty simple. Constructor, destructor. I don't even believe those do anything. Those are the nodes. And then up here was the... So I just have it, if there's something in the queue and it decided to kill the queue, that's the problem. So I just have it print out a warning. This is just a way to debug your code. You should never kill the queue until you've emptied it, because those are pointers to objects, so there will be memory leaks if you kill it too early. Add, you get to add, and it will return true if added successfully. Remove, it will give you the pointer to your object when you remove it. Get length, I'm going to fix or change, possibly. I'll have to think about that. I'll probably try to implement this queue with the Linux, not Linux, the networking package or library that I'm going to try to make, and see what type of accesses I want to the length. Do I want it to be blocking to all adds and removes? Do I want it to be, I don't know. We're going to see. I might have a remove if empty, or remove if full, or not full, but contains something. I don't know how I'd word that. So those are the basic functions. Then you have the private functions, so only it can access these request first access. So there's going to be a first node and a last node. That's how I'm working my queue. So if we just say, I'll just try to do, so first, last, each one, I should probably do that last. The first one will have a pointer to the previous one. It's got a previous pointer. As you can see here, the node has constructor, destructor, which do basically nothing. I believe it's absolutely nothing, because they return the content, so they don't want to destroy the content. And the previous node we don't want to destroy, because killing a node would then destroy the entire queue, which would be terrible. So I just have content, whatever it stores, node previous, so it's only got a one-way reference. The first pointer will point to the next pointer, so we'll just say that. 1, and then 1 would point to 2, so on, until you get to the last. So a remove would just take the first one, eat it, and then make this the new first one. A remove, that's a remove, an add would take another one, a new last. It would first, it creates the last, it then creates the reference from the previous last node to this, I'm call this just 2 for now, to this last node, and then it changes the reference of last to the new last. And so that's how I'm handling that. And because of this, the way that this works, when you remove, you only need to access the first object. When you add, there's the special case that you might need to access the first, but most of the time you are only going to have to access the last. So if you look in here, I'm using mutexes to be thread safe, and basically you have to request first access. If you don't request, that's the problem, which is why these are all private methods, because you don't want user code trying to do this. You want it to be hard-coded in that it works. So just a simple locks it, unlocks it. And so if the next person requests access to the first object, then it will lock it, and then if another one tries to request while the other one still hasn't unlocked, it will reach this, and because it's a mutex, it can't get any further than here until that other thread unlocks its access. So if we look here, we'll start at the top. The add, you'll notice request last access goes throughout the whole thing, and the request first access only goes through part of it. That's because I don't need to have access to the first object want something out of here. So I relinquish the access as fast as possible, just in case something else wants to remove and it needs access to the first object. It's fairly simple. If it's not first, meaning if the first does not exist, um, you need to add it to the first node and the last node, because the first and last are the same node when you only have one node in a queue. And then I have to make sure to relinquish access here instead of down here, because it's going to return. I don't know when I'd return false. I'd have to look into that, see if there'd be any information I could have in that. When would it ever fail? I don't know. It shouldn't, but I could be wrong. None of these are methods that would fail. These are blocking, so they won't do anything, but you can always set an object to, even if it was null, it wouldn't kill it. It would just be unpredictable. So none of these I see would ever fail to add, but maybe I'll think of something. Remove, very simple. If something exists, remove it. Otherwise, don't remove it. Just return null, meaning, hey, we didn't find anything. That's just my way of covering that, making sure that they know it's not just some random value. Return null, 0, so that they can clearly see. So, yep, just get the first, set everything how you need to. You get the access, you relinquish the access, but we only need access to the first object. Then get length was very simple, and I told you that I may want to change that, or I may have it such that I don't know. We'll see what I will want to do with the length. Because it's possible that I'll want to do a remove if, and then since it requests first access, nothing can touch the first one, so it would be able to remove that, and this should work, and then it will return null. I don't know. We'll see. I could also possibly have a method that would return, you say remove, and it just goes in an infinite loop or an infinite wait until there is a first object. So it could be a remove that always removes something, it's just a matter of time. But that would be blocking, and that's not optimal. So I probably wouldn't want to do that. These are just the locks and unlocks, I already showed you that. This is simple, just assign the content to that node. That's the constructor for the node. And you may notice, I don't know who's watching, so I'll try to explain this. I have a header and a CPP file, and I have all my template code in the CPP file. Most times people don't often do that because of the fact that if you try to do this, it will throw errors. There are ways around this though, and the way that I found, I researched it, if you include both the header and the CPP file, notice that because it's a template, you can actually use the template code in your CPP file, which is cool. So that's what I did. I was able to get that to work. You can see this is just my test thread. This whole application right here is a test thread because I won't be using Visual Studio to compile for my Linux build. I'm not going to deal with that. I'll use GCC or whatever that is. So all of this is all that I have done right now is the queue. This test application I showed you, it creates adds 3 basic items just for fun. I wanted to do that. It then creates, however, array size number of threads, which right now is 100. So 100 threads. It then waits for them to finish, but those threads add and remove 1,000 items. And they don't always remove their item, because they just remove the item. So if they added and someone else added, and then they remove, they're going to remove the other thread's item. So it's not about being specific. I just wanted to make sure that adds and removes going constantly in 1,000 different, 100 different threads would all be safe, and it would end on that last number just like it should. So yeah, that's the project so far. I want this to be helpful for me as a programmer, but I also want to be able to help anyone with their code, just so they can see see the reasoning behind what I'm doing. So if anyone ever has any questions, please ask, and I will try to address those either in the comments or in a future video. Um, so yeah, thank you guys for watching. And this is going to be it for today. I don't know how often I'm going to release videos, but hopefully whenever I make a decent amount of progress. I don't want to show you coding because it would be a lot of silence, and I also want to keep my editing to a minimum because of the fact that I don't have a ton of time. I currently work full-time, and I have a class at school, and then there's this project, so I don't have a ton of time to edit. Um, so yeah, thank you guys for watching, and hopefully you guys like this. Please give me any suggestions. And yeah, thank you guys. See.